While we are on the subject of density, let's use it to complete a mini-lab that would put in perspective the size of atoms. We know that atoms are small, very small, but how small is very small? To get a more tangible idea on the size of atoms, let's find out how many atoms thick is a piece of aluminum foil. For this lab, we would need aluminum foil, ruler, scissors, electronic balance, and reference table. Or specifically, we need one piece of information from the reference table. We need information about density of aluminum. To get on with this lab, we will measure and cut a square of aluminum foil. The square will be 10 by 10 centimeters. We will try to avoid handling aluminum foil too much to avoid leaving on it the oil from our fingers. That would increase the mass and our data would be skewed. We'll place the foil square on the scale and we'll find out and record its mass. People in class will collect the data. People at home will find the data collected for them on Google Classroom. That's it. Practical part of the lab is over. Now we need to find out how many atoms of aluminum are stacked on top of each other to create thickness of the foil sheet. To do that, we would need to know the thickness of the foil, the height of the foil, and height of a single atom of aluminum. We will divide the height of aluminum foil by the height of an atom and thus find out how many atoms thick is the sheet of aluminum foil. But here comes a question. What height of the foil am I talking about? Foil appears to be a flat sheet with only length and width. Well, there is also thickness of the sheet. Yes, it is very small, but it must be considered to be the height of the sheet. As flat as it is, our aluminum foil square is still a three-dimensional object with length, width, and height. But how do we measure the thickness of the sheet? The ruler won't be much help. Its scale is too big for something that is so small. So we have to find a different method. Volume of cube is calculated as length times height times width. If the cube is made of the substance with known density, the volume also can be calculated as mass over density. These two things can be equated. Density of aluminum is 2.70 grams per centimeter cubes. So now let's plug the numbers. 10 times 10 times height, which we don't know, equals mass over 2.70. And mass has been measured in our experiment, so plug in the number of the measurement. And voila, you can solve it for height. Here is another important question. When you solve this equation for height, in what units your height will be? Let's quickly assign the units in this equation so you can see what units the height will come out to be. Once you've calculated the height of the aluminum foil, you need information about the height of aluminum atom. That information also can be found in reference table. Well, specifically, we can find there information that atomic radius for aluminum would be 124 picometers. Well, if that is radius, then the full height of the atom must be twice this number. So the height of aluminum atom would be 248 picometers. All that is left for us to do is to divide the height of the foil by the height of the atom of aluminum. But here comes a warning. Consider in what units express the height of the foil and in what units express the height of the aluminum atom. Here are conversion factors that you might need to resolve this problem.